Show that the equation 5 cos squared x equals 3 open bracket 1 plus sine x close bracket can be written as 5 sine squared x plus 3 sine x minus 2 equal to 0. 5 cos squared x equals 3 open bracket 1 plus sine x. What we need to do is expand the bracket on the right hand side. 5 cos squared x equals 3 plus 3 sine x. Now what we need to do is remember the fundamental identity, which is cos squared x plus sine squared x equals to 1. I need to make cos squared x the subject, so cos squared x equals 1 minus sine squared x. I chose cos squared x because I've got cos squared x here and I've got sine x here, so it's best to have sine x, sine squared x with sine x. So I'm going to replace cos squared x here. Get 5 open bracket 1 minus sine squared x equals 3 plus 3 sine x. Then I need to expand the bracket on the left hand side. 5 times 1 is 5 minus 5 times 1 sine squared x is 5 sine squared x equals 3 plus 3 sine x. I need to move all the left hand side to the right hand side because these are plus and minuses. So I get 5 sine squared x plus 3 sine x plus 3 minus 5 equal to 0. And that gives 5 sine squared x plus 3 sine x minus 2 equal to 0. B. Hence, we need to solve for x for the boundary between 0 less or equal to x less or less than 360 degrees. We already got this equation, we've already simplified the equation, and I remember we got 5 sine squared x plus 3 sine x minus 2 equal to 0. So we can say let y equal to sine x, because I recognize a quadratic function here. So that will be 5y squared plus 3y minus 2 equal to 0. That reminds me of a quadratic function, ay squared plus by plus c equal to 0, where a equals 5, b equals 3, and c equals minus 2. In order to factorize this, we need to find AC, and AC is minus 10. I need two numbers that are giving me minus 10, and when I add them together, it will be plus 3b, and that will be 5 and minus 2. So if I put y here and y there, that will be equal to 3y. So what I need to do is replace 3y here with 5y minus 2y. So I get 5y squared plus 5y minus 2y, that's still 3y, minus 2 equal to 0. So there's a common factor here, and that's 5y. And there's another common factor here, that's minus 2. So I can now say 5y open bracket y plus 1, and then minus 2 open bracket y plus 1. If I expand the bracket back, I should get the same thing at the top. 5y times y is 5y squared. 5y times 1 is 5y. minus 2 times y is minus 2y, minus 2 times 1 is minus 2, and so yes, we got the same thing back, and that equals 0. Now what I need to do is, there's another common factor here, and then what's left is 5y minus 2. So y plus 1 is a common factor. So I get y plus 1 and 5y minus 2 equal to 0. So what I need to do is set that bracket to 0 and set that bracket to 0. Y plus 1 equal to 0, y equals minus 1. That meant sine x equals minus 1. Here we've got 5y minus 2 equal to 0. Therefore, 5y equals 2, y equals 2 over 5. Again, that meant sine x equals 2 over 5. So therefore, we need to now solve for x in both cases. When sine x equals minus 1, what that meant is x equals inverse sine to minus 1, open bracket minus 1. And also when sine x equals 2 over 5, x equals inverse sine, open bracket 2 over 5. If we sketch the curve of sine, we know what that looks like. Start from 0, up to 1, back to 0, to minus 1, back to 0. Between 0 and 360 degrees. So that is 1, and that is minus 1. So this is 270 degrees. That's when sine is minus 1. So the value for x here is going to be 270 degrees. For 2 over 5, we need to use our calculator. We go to turn on the calculator, make sure it's on degrees. If it's not on degrees, you need to press Shift menu, 2 for angle unit, and then 1 for degrees. Then look on the top of your screen, you will see D, and that implies it's in degrees. Now you need to press Shift Sine, that gives you inverse sine. Press the fraction key below option key, and that will be 2. Bring the arrow key down, you get 5. Move the arrow key to the right, close the bracket, and then you get 23.6 degrees. So x here equals 23.6 degrees. To find the rest of the value for sine, we only know between 0 and 360 degrees is 270 for when x is minus 1. But for 23.6 degrees, let's use a cast diagram. That's 23 there, and there will be another 23 on this side. So both sides here will be 23.6 degrees, and this side will be 23.6 degrees, because it's the height of the sine, it's the height of y value that matters, and they both have the same height here when I use a unit circle diagram. And so the angles I'm looking for will be that to there. That's first one at 0 degrees. This is 90 degrees. And this is 180 degrees. So the second angle I'll be looking for is all the way to there. So that will be 180 minus 23.6 degrees. 156.4 degrees. So now we got the value for x. So the x value will be 23.6 degrees. That's the first value. And then the second value will be 156.4 degrees. and the third value will be 270 degrees. And those are the values that we're looking for x.